Our planet, Earth, is a marvel. It teems with life in every corner, from the deepest oceans to the highest mountains. It boasts vast oceans that cover over 70% of its surface, sprawling continents that house diverse ecosystems, and a protective atmosphere that shields us from the harshness of space. But have you ever wondered where this magnificent sphere came from? How did it come to be in this perfect balance? How did it arise from the chaos of space, from the seemingly random dance of cosmic dust and gas? The story of Earth's birth is a tale 4.6 billion years in the making. It's a story written in the stars, in the very fabric of the universe. It's a cosmic drama of dust, gas, collisions, and ultimately life. A tale of transformation from simple particles to complex organisms. Imagine a time before planets, before even the sun, a time when the universe was a vast expanse of darkness and potential. Picture a vast swirling cloud of gas and dust, a nebula, floating in the emptiness of space. This was the solar nebula, the birthplace of our solar system. This was the solar nebula, the birthplace of our solar system. Within this cloud, gravity began to pull particles together, forming clumps that would eventually become planets. This nebula was not unique. Such clouds exist throughout the universe, each one a potential cradle for new stars and planets. These clouds are the remnants of past stars, the ashes of ancient celestial giants, and the seeds of future ones. They are the universe's way of recycling itself. Our own solar nebula held within it the basic ingredients for everything we know. Hydrogen, helium, and trace amounts of heavier elements all swirling together in a cosmic dance. The solar nebula was a chaotic place, a swirling mass of gas and dust, teeming with potential. Gravity acted upon the dust and gas, pulling it inward, creating a gravitational dance that would set the stage for the birth of our solar system. As the cloud contracted, it began to spin faster and faster, like a figure skater drawing in their arms, conserving angular momentum and accelerating the rotation. This spinning motion flattened the nebula into a disk, a vast, rotating pancake of cosmic material. At the center of this disk, the material became incredibly dense and hot, forming a bright, searing core. The core of our future sun was forming, a nascent star that would one day light up our skies. Within the swirling disk, tiny particles of dust collided and stuck together, beginning the slow process of building larger structures. This process, called accretion, gradually built larger and larger objects as these particles merged and grew. Over millions of years, these objects grew from dust grains, tiny and almost invisible, to pebbles, small rocks that clumped together, to boulders, and eventually to planet-sized bodies massive enough to shape their own destinies. This is how our Earth began its journey, from a cloud of dust and gas to the vibrant, life-sustaining planet we call home today. While planets were coalescing in the disk, the center of the nebula continued to heat up. The pressure and temperature at the core became so intense that hydrogen atoms began to fuse, releasing incredible amounts of energy. The sun, our very own star, was born. The sun's ignition marked a significant change for the early solar system. A powerful solar wind, a stream of charged particles, erupted from the young star. This wind swept through the disk, pushing away leftover gas and dust. The planets, now large enough to withstand the solar wind, settled into their orbits. Section 4. A World in Chaos. The Early Earth. The early Earth was a far cry from the planet we know today. It was a tumultuous and violent place, a world in constant upheaval. It was a hot, molten world, constantly bombarded by asteroids and comets left over from the solar system's formation. These celestial bodies, remnants of the early solar system, relentlessly pounded the young Earth. These impacts generated immense heat, keeping the surface of the young Earth in a molten state. Volcanic eruptions were frequent, spewing lava and gases into the atmosphere, contributing to the planet's fiery landscape. This period of intense bombardment, known as the Late Heavy Bombardment, played a crucial role in shaping Earth's future. The relentless impacts not only molded the planet's surface but also influenced its geological and atmospheric evolution. The impacts delivered water and other volatile compounds to Earth, which would later form our oceans and atmosphere. These essential ingredients for life were brought to our planet by these cosmic visitors, setting the stage for the development of life. However, this early Earth was a harsh and unforgiving place. The surface was dominated by volcanic activity and the atmosphere was thick with toxic gases, making it inhospitable for any form of life as we know it. Life, as we know it, could not have survived in such extreme conditions. The environment was too volatile, too hostile, and too unpredictable for any form of life to take hold. It would take millions of years of gradual change and stabilization before the Earth could support even the simplest forms of life. Section 5, Lunar Lullaby, the Moon's dramatic entrance. One of the most dramatic events in Earth's early history was the formation of the Moon. The giant impact hypothesis suggests that a Mars-sized object named Theia collided with the young Earth. This collision was so powerful that it ejected a massive amount of debris into space. This debris, caught in Earth's gravitational pull, gradually coalesced to form our Moon. The impact also tilted Earth's axis, giving us our seasons, and sped up its rotation, shortening our days. The Moon, once a fiery ring of debris, became a familiar presence in our sky and a stabilizing force for our planet.